So we're multiplying radicals, part 2. Once we've got that written down, flip over to page 57 for our objectives. So yesterday we talked about radicals times radicals and radicals times expressions. We're going to spend a little bit more time with the radical times expression, the distributive property. And then we're also going to talk about radicals that require FOILing, so expressions times expressions. Or FOIL. So we have expressions times expressions and radicals times expressions today. Once we've got that written down, flip on over to 64. At the top of the page, radical or multiplying radicals part 2. So multiplying radicals part 2. We are essentially going to have the same steps that we had yesterday, just one before. And the one before will simply just say distribute or FOIL. So the first step we need to do today is either distribute or FOIL. So we're distributing or FOILing, and then we have the same instructions and directions as yesterday. So the second step is the first step from yesterday. So we're going to multiply our coefficients. So we're going to distribute or FOIL, and in that we're going to multiply our coefficients. Then we're going to multiply our radicands. And lastly, combine like terms or simplify. So we're distributing or FOILing, multiplying our coefficients, multiplying what's in the radicands, and combining our like terms and simplifying. So let's take a couple look at examples of distributing for some review from yesterday. So we have the square root of 6 times the square root of 8 minus 3. Yes. So, what shall we do first?
Distribute.
We can distribute. So we distribute this 6, square root of 6 to both terms. Square root of 6 times the square root of 8 gives us
48. Square root of 48.
square root of 48. And 3 times the square root of 6 gives us negative 3 square root of 6. Can we factor 48? What nice number is in 48? Maya? 4 and 12 works? 4 is perfect, giving us a pair of 2's. 12. We can simplify that with 4 and 3, giving us a pair of 2's. So we have 2 times 2, which is left with radical 3. And then if we simplify 6, it's just 3 times 2, so we have no pairs. So it's 4 radical 3 times 3 radical 6. Can we combine that? Because we have a 3 here and a 3 here, right?
No.
So our final answer is just 4 square root of 3 minus 3 square root of 6. If we were to do another example, let's say we had the square root of 5 times the square root of 10 plus 4 square root of 3. So we need to distribute again. So we multiply 5 square root of 10, or 5 square root of 5 times square root of 10. And that gives us square root of 50. Square root of 5 times 4 square root of 13, or 3 is 4 square root of 15. What perfect number is in 50?
2 and 25.
2 and 25. 25 is perfect, giving us a pair of 5s. So we have 5 square root of 2. If we break down 15, it's 5 times 3. We don't have any pairs, so we bring that down, plus 4 square root of 15. So we all feeling confident on distributing radicals. Okay, so what does FOIL mean? What does the acronym FOIL stand for?
First, outside, inside, last.
First, outside, inside, last. First, outside, inside, last. We're going to use FOILing with multiplying radicals. So let's say we had 3 plus the square root of 3 multiplied by 8 minus the square root of 3. So now we have an expression times an expression that contains radicals. So first times first is 3 times 8. That gives us 24. 3 times the negative square root of 3 is? Negative 3 square root of 3. Inside, 3 square root of 3 times 8. 8 square root of 3. Square root of 3 times the negative square root of 3 is? Negative square root of 9. So now, the last step comes into play. We need to combine like terms and simplify. Are there like terms?
Yep.
Where?
Middle.
The middle. So we have negative 3 square root of 3 plus 8 square root of 3 giving us
5.
5 square root of 3. What's the square root of 9? 3. So minus 3. And the 24 comes down.
It froze.
It froze.
Error 404. Projector not working.
So, Tony.
How'd you get negative 3 for outside?
Oh, there we go.
Right here.
Yeah, how'd you get negative 3?
What's the square root of 9?
No, second.
Where? Right here?
Yeah.
So this is a subtraction sign right here. So 3 times the negative of the square root of 3? Okay. So now there's one more thing we can combine. We have a 24 and a negative 3, giving us 21 plus 5 square root of 3. And that is our answer.
Very long.
It's no different than doing a FOIL problem
No,
with regular variables, right?
not that hard.
No. So let's try another one. Let's say we had 9 plus the square root of 2 squared. So we have 9 plus the square root of 2 squared. What's another way we can rewrite this?
9 square root of 2 times 9 square root of 2.
9 plus the square root of 2 times 9 plus the square root of 2. And now we can FOIL. First times first is 81. Last, or outside times outside is
18.
9 times the square root of 2 is 9 square root of 2. Inside 9 times the square root of 2 is 9 square root of 2. Last, radicand times radicand is square root of 4. So we have 81. Combining like terms, what do we get? 18 square root of 2. And what's the square root of 4? 2. So 81 plus 2 is 83 plus 18 square root of 2. Sorry? So, are we feeling confident with foiling with radicals, or we need another example? Thumbs up if we're good.
We're good.
Good?
Ready to go.
Taco Bell good to go?
Taco Bell was-
Talk about that.
That was an old thing.
Taco Bell was awesome.
Okay, so we're good? Homework? Ready for homework?
We're lit. We are lit.
Okay, I'll put homework on the board. We have 13 through 18 and 36 through 44. I think it's 14 problems. So you have 10 minutes to start on homework. Ian and Alex. No. Yes, Damon. Paper copy? Yeah, I'll put one out. I'll go put one out.
Also, I just realized you have a sort of an accent. When you say yesterday, you sound like you're from the Bronx. You say yesterday.
Yesterday?
Yeah, yesterday.
I can't understand.
Southern California.
Wait,
That's why.
wait, wait.
I think in California, they all have that.
Okay, I'll put it up on the board.
Really? Just look that up online. First video you see, we'll probably read it.
Well, can I just have a paper copy?
So our notebooks are out, ready for notes. Open to the table of contents. Our table of contents, we're on page 64. We're doing multiplying radicals part 2. So page 64. Page 64, multiplying radicals, part 2. Yes. Depending on how we do on this, 2. So multiplying radicals, part 2. Multiplying radicals, part 2. Flip on over to page 57 for our objectives. Yesterday we talked about multiplying radicals. Radicals times radicals and radicals times expressions. Today we're going to continue with radicals times expressions. We're also going to add expressions times expressions. So expressions containing radicals multiplied by expressions containing radicals. Another way to think of this is FOIL. So yesterday we talked about radicals times radicals, radicals times expressions. We're going to continue that today with a couple more examples, and then expressions times expressions. So flip on over to page 64, and we can start our notes for the day. So, page 64. Multiplying radical expressions. Part 2. So, multiplying radical expressions, part 2. So, yesterday we had 3 steps to follow. Today we'll have 4. Our first step will be to simply distribute or FOIL. So we're going to distribute or we're going to FOIL, depending on what the problem looks like. So we're going to distribute or FOIL, and the rest of our rules are what yesterday's were. So what was our first rule yesterday? So we're going to multiply our coefficients. So we're multiplying our coefficients. What is the second step from yesterday, third step today? We're going to multiply our radicands. So step 3, multiply our radicand. And our last step,
Simplify the radicand.
our last step will be simplify and combine like terms today. So simplify radicand and combine like terms. So, our 4 steps are distribute or FOIL, multiply our coefficients, multiply radicands, simplify radicands, and combine like terms. So those are our 4 steps. Let's put those in action. So let's say we had the square root of 6 times the square root of 8 minus 3. We did a lot of problems on our homework that looked a lot like this.
Okay.
How are we going to solve this problem?
What you have to do first is we're going to distribute the square root of 6. Wait, yeah. To the square root of 8, which will equal the square root of 48.
Very good.
And then you would distribute the square root of 6 to negative 3, which would give you the square root of negative 18.
Is that right?
No.
What was our mistake? Haley. Why?
Oh, because you can't have.
Let Haley do it. Because 3 is a coefficient and 6 is a radicand. So we can't multiply coefficients and radicands. So, as D'Angelo said, we have the square root of 6 times the square root of 8, which gives us the square root of 48. And as Haley said, we have the square root of 6 times negative 3, which gives us negative 3 square root of 6. Where where do we go from here?
40. 6 times 48.
6 times 48 is a really big number.
Well, I got it.
3 times 16 works perfectly, Abby. 6 times 8 works, but
288.
we're trying to factor, not multiply. So Abby said 16 times 3 gives us 4 and 4. So what are we left with in the radical? We have 4 square root of 3.
Wow. So I thought you do the coefficients, so it would just be negative 3, and then you multiply the right.
And then we simplify.
So you just simplify first.
No, we did 6 times 8, which gave us 48, right?
Yeah.
And then we simplified the square root of 48.
To make it easier, so then that's when you go back up.
So, we can't do anything with the square root of 6. So 4 square root of 3 minus 3 square root of 6. Can we combine these?
No.
Why not? Because they're different radicals. Good. So there's our answer. Let's try another one. Let's say we had the square root of 5 times the square root of 10 plus 4 square root of 3. So now we have square root of 5 times the square root of 10 plus 4 square root of 3. So, what are we going to do here, Tylee? We have to have the 4 in front of it. So as Tylee said, the square root of 5 times the square root of 10 gives us the square root of 50. So 5 times 10 gave us 50. Square root of that. 5 times the square root of 5 times the square root of 3 gives us the square root of 15. And we have to have that coefficient of 4 out front. Let's factor 50.
225.
2 and 25 works.
And then you got 5 and 5.
25 is perfect, giving us 5 and 5.
5.
So we'll go ahead and circle it. 5 is the coefficient and 2 is the radicand. Can we do anything with 15? It factors the 5 and 3, so what does that mean?
You can't because
They're not perfect. We don't have any pairs that we can have, so we just bring it on down as 4 square root of 15. Giving us an answer of 5 square root of 2 plus 4 square root of 15. So recollecting our multiplication of polynomials, what does FOIL stand for? First, outside, inside, last. So that's what FOIL stands for. And now we're going to use FOIL with radicals. So, let's say we had a problem that looked like 3 plus the square root of 3 times 8 minus the square root of 3. So this is the problem. We are going to FOIL it. We have to. We're going to FOIL. So first times first is 8 times 3. 8 times 3 is 24. Outside, what's that going to look like? So negative 3 times the square root of 3. What's the inside going to look like? 8 times the square root of 3. Eight square root of 3. Good catch, Zach. Way to catch yourself. So, and the outside, or the last terms, square root of 3 times the square root of 3 is Square root of 9. So we had 3 times 8 gave us 24. 3 times negative square root of 3 gave us negative 3 square root of 3. 8 times the square root of 3 gave us a positive 8 square root of 3. And square root of 3 times negative square root of 3 gave us the square root of 9. So now we need to, what? Simplify and combine like terms. Where are our like terms?
Radical 3.
We have combined like term possibilities with the radical 3, so negative 3 plus 8 is 5 radical 3. We bring down our 24, and what's the square root of 9? So we have subtracted 3. We can still combine like terms, can we or can we not? We can. So 24 minus 3 is 21 plus 5 square root of 3. That is our answer.
What is that, 5 negative or positive?
Positive. Why is it positive, somebody? John Jones.
Because when we combine the terms, we added positive
It's 21.
So how did we get to 21? We had 24, and then we had subtraction of the square root of 9. What's the square root of 9, D'Angelo? 3. So we have 24 minus 3.
Oh, you didn't add the 5. Okay, yeah.
So 21 plus the square root of 21 plus 5 square root of 3 is our answer. Let's try one more. Let's say we had 9 plus the square root of 2. That quantity squared. Good, Tylee. We can go ahead and put 9 square root of 2 times 9 plus the square root of 2. So now we can FOIL. First times first is 81. First, our outside is 9 times the square root of 2. 9 square root of 2. Inside, 9 times the square root of 2. 9 square root of 2. And the square root of 2 times square root of 2 is square root of 4. Combining like terms, what do we get? 9 square root of 2 plus 9 square root of 2. Good, Trey. 18 square root of 2. Then we have our 81 plus 18 square root of 2. What's the square root of 4? Combining like terms, what do we get? 83 plus 18 square root of 2. There is our answer. So, using FOIL with radicals, does it make sense? Thumbs up if we're good. Thumb sideways. We're good. Do we need to do one more example? We can do one more example. We can do one more. So, one more example. Let's say we have the square root of 6 plus the square root of 5 times the square root of 7 plus the square root of 8. This one has all square roots. So first times first. So we get the square root of 42 for first times first. Outside. Square root of 6 times the square root of 8 gives us the square root of 48. Inside. We get the square root of 35. Outside, last. Plus the square root of 40. Can we simplify any of these? So if we did 42, that'd be 6 and 7. What about 48? We can simplify that, right? 16 and 3, Zach, right? 16 and 3. Giving us a pair of 4s. What about 35? That factors to 3 or 7 and what? 5. What about 40? 4 and 10. There's a pair of 2s, 10 we can't do anything with, right? So our final answer will be the square root of 42 plus what? 4. What's left in the radicand? Square root of 3. What about the next term? Square root of 35. And the last term? Plus 2 radical 10. That's your final answer. So today we talked about multiplying radicals. Radicals times expressions and expressions times expressions. Are there any questions? Our homework is posted on Google Classroom. Let's start working on it. We have 8 minutes to finish.